Hey, what's going on, guys? Hope everyone's doing really well. I say that every week, but I really mean it. So this video is going to be real long. Just up front, I was writing down a couple thoughts and notes about this, and it turned into a lot more than I expected. But it's going to be long, and actually this is a video that's a follow-up to this other one I did over here about how much you should know. So please just go check that out if you haven't and come back here. All right, so whole point of this video is I want to kind of talk about a journey or like the whole stack of technology for one particular use case. The example I want to use in this video is going to be revolving around cell phones because that's what I'm most comfortable with, but actually all these steps, you can probably translate them to other areas like developing a new console, developing a new PC, or just developing anything really new. So we're going to use cell phones as the example in this video. I wrote down 10 important points that I want to talk over, from really low-level hardware stuff all the way to application programming. So I wanted to cover kind of the whole stack, and that's going to be this video. All right, let's do it. Phones, right? You hear about it in the news all the time. Every single year, Apple has these crazy announcements where they announce new phones every single year, like iPhone 6, 6S, 7, 7S, 8, the pattern goes on and it's very consistent, which is good, right? So every single year, consumers can expect a new phone. Every single new phone that you get in the store, Apple has actually been working on that for probably a couple years already, right? It's actually just a huge pipeline. Every time we get something new, there's already a newer thing in the works, right? And what we're getting, people have been working on that for a while. At the core of a new phone, at the core of like the iPhone 7, it's always going to be a hardware change, right? That's the core, that's what spurs it all, right? A core hardware change. If you were just doing software changes, that doesn't need new phones, right? Software is just you code it up, you test it, you release it, and you download an update. That's software changes. But every time a new phone comes out, or anytime anything new comes out, at the core, it's always new hardware, right? So we're going to go through 10 steps, and let's get into step number 1. All right, so step number 1, we're going to start this 10-step kind of journey thing, but obviously I'm leaving out a lot of details, so please go digging if none of these steps or some of these steps don't make any sense. But at the very start of everything, we're going to start with brand new hardware. So let's just take a couple hardware examples first, right? There's hardware designers designing specialized components inside our phones, right? Really specialized things doing math, detecting motion. Specialized components are all designed by hardware people, and there's other more system level hardware guys that put all that stuff together, right? But it's always iterating, just like software, just not as fast. Just for example sake, let's say the new hardware in this new phone coming out is going to be a brand new processor, right? We decided to up the processor. Maybe the memory stays the same, but we also upgrade the graphics processor and we add maybe a new motion detector. So some hardware components get upgraded, but it doesn't have to be all of them. So let's just take the CPU, central processing unit, as an example first. Remember that every single CPU is designed and implemented for a specific specification, or ISA. Remember that acronym? So remember, there's one ISA, maybe it's x86, but you could have many different implementations for that. So Pentium 1, Pentium 2, Pentium 3, 4, 5, 6, they're all implementing the same specification, they're just doing it better. All right, step number 2 is going to be hardware, software, emulated testing. And what does that mean? So every time the hardware updates, the software also has to update a little bit as well, right? You can't just update all the hardware and have the software be the same, right? It's just not going to work. So how do you actually test out new hardware before it physically comes out, right? You can't just, it's not like software, you change a line of code, right? You have to get something manufactured. So that's really difficult. And how do you test that? So there's actually two main ways, at least two main ways that I know of how you test on new hardware before the hardware actually comes out, all right? 2 ways that I know of, but there's probably many more. The first way is that there's actually people that create software that emulates hardware. All right, so before you have the big hardware system that actually comes back from the factory, there's actually programs, big programs that emulate how the hardware would behave. So people actually work on that software, and hardware designers also contribute to that software, so you can kind of mimic what the hardware would do if you did certain things. All right, so it's kind of like using software to mimic new hardware. Besides using kind of a simulated software type of thing, you can actually use this thing called an FPGA. So I think this stands for Field Programmable Gate Array. And what, it sounds complicated, but what that pretty much is a piece of hardware, actually real physical piece of hardware that you can customize to do different things, right? So just think of it as a very customizable piece of hardware. So what hardware designers do is that before the hardware can physically be really built somewhere in Asia, they can program all the stuff and put it onto an FPGA for testing. This is actually really good because this is much closer to real hardware than simulated software is. It's like a physical thing, and they can actually get really big. So that's the second way of kind of customizing hardware to mimic what's really going to happen. But in the end, this is kind of emulated testing that has to happen before you get the real thing back, but you have to do it, right? You can't just like, oh, my designs are good, let me just give it to Taiwan and expect it to work when you get back too, right? There's a lot of testing that goes into hardware as well as software before it's even fabricated. Okay, so step number three. Step number three is going to be actually getting this hardware created. So most companies that you know of, Apple or Qualcomm, they're not actually manufacturing companies, all right? They just do the design of all this hardware, all these cool new processors. They design it. They get this huge plan together, specification, what it's supposed to look like, how it's supposed to behave, but they just do the specs. But once that's all done, they send it to Taiwan to get it actually fabricated or manufactured. So there's like huge labs over there, and like people are wearing, you know, crazy jumpsuits with no static electricity that you might see in the movies or something. But most companies that you know of, they just design it and then they send an order out to Taiwan, and Taiwan's going to take that order, fulfill it, and you can imagine how many chips they have to manufacture, right? If we're making a new iPhone 6, that's a lot of new things to be built. So someone else gets the order, builds it all, usually in batches, and then they send it back to Apple when it's ready. All right, so that's kind of step three in a nutshell, is that we're going to get this hardware finally created. Step number four now, it's starting to get a little crazy, but this is when the real hardware comes back and kind of the real testing and verification can begin. This is going to be actually a really big milestone, right? For a long time, you've been testing in these emulated hardware environments. Finally, the chip, or they actually call it taping out, but once you physically get the real thing back, you have the real thing now, right? You don't need some weird simulation. You can actually test the real thing, and this is when things start getting a little crazy. So worst case scenario, it doesn't work. It's a brick and you have to get it remanufactured and it costs your company millions of dollars. Worst case scenario, but that probably happens very rarely if you tested it well. So I think you guys would be surprised that often when these things come back, there's hardware bugs in here. People always think that all the bugs are in software, but actually there's also a lot of hardware bugs, and things can still kind of work even if there's hardware bugs. So we got this hardware back from Asia somewhere. We finally got it back. Everyone had this huge party if it actually works, and everybody's going to be really sad if it doesn't work. But this is when the real verification starts, and this is called hardware verification. Pretty simple. It's exactly what it sounds like, but the people that do this job, they're not really software engineers. They're kind of they're more hardware, but they're just intimately familiar with how the hardware is spec'd out and how it's supposed to work. And they write a bunch of scripts, pretty much testing scripts, which they write these scripts and it just tests the hardware for all the edge cases, like just pounds it with test. And all this is really doing is that you have to verify that the hardware behaves like it should behave. Also, remember that when these things come back, they're really complicated, right? It's not just one processor. We're talking about many different processors like quad-core application processor, graphics processor, motion processor, modem. All that hardware has to be verified, and there's people to do that. At this stage in the game, the hardware verification people might work really closely with the hardware designers if things don't really work out to spec. But by this point, the hardware designers are already working on the next big thing, right? By the time the real chip comes back and you have it in your hand, you just have to verify it and it should work. But the people designing the hardware, they're already doing the next generation thing, all right? So it's always this huge pipeline. All right, so things are getting a little crazy now. So we're almost halfway done, but this is going to be step number 5. And this is going to be the first step where software starts coming into the picture. All right, so software, low-level software always comes first when this new hardware stuff comes out, right? So while the hardware verification team is verifying all this hardware and making sure it's working, low-level software starts coming in slowly into the picture to start actually writing code for this new stuff. Like firmware, bootloaders, really low-level device drivers, these things start coming into the picture at this step. Eventually, the hardware verification people will be like, all right, check, it's good to go, the hardware works, but there's kind of like this parallel overlapping period where hardware verification is verifying the hardware, and slowly, as you're getting more confident that it's good to go, software comes into the picture. Software at this really low level actually works really closely with the hardware verification team, right? Because in the end, the hardware guys are verifying some kind of hardware behavior, and the software guys, they're trying to make a driver for it. This happened to me a couple times, but when I was writing like a new feature, maybe I was writing an updated device driver for this new hardware that was coming out, but it wasn't working as expected. Like it wasn't doing what I thought it should be doing from whatever big manual that I was reading. When that happened, I would often go to the hardware verification person that actually verified that feature already in one of his big scripts. So I'd just be like, oh yeah, you tested that feature already, right? Can I just see your script and how you did that? And pretty much what I was doing is I was taking chunks of that person's script and I was wrapping it up in a device driver with some interfaces, right? So you can kind of see how that interaction works. Low-level software, let's keep going up. All right, we're on step number 6, but this is going to be higher level software. So we got the hardware back. It was verified. It physically works. The electricity runs like it should run. Low-level software has also been written and it's doing its job. Now it's time for higher level software to be put on. You can imagine when these phones boot up for the first time, low-level software is the first thing that happens, right? This is like your BIOS or the bootloader. Low-level software does all the initializations first, and then it loads the operating system. Operating system loads different applications, but we slowly get into higher level software. So let's talk about that a little bit. Who's doing all this stuff, right? You might be asking yourself, does somebody do all these things? Well, actually it could sometimes be, yes, one company like the Apples, they can do everything in this list pretty much besides fabrication, but also smaller companies can do bits and pieces of different things, right? You could have like companies that just specialize in hardware design and that's all they do. So big companies can kind of do the whole thing. Like Apple controls this whole stack, which is why they're Apple, but that's kind of the rare case. If you're a smaller company, you're probably just doing 1 or 2 levels in the stack. Let's just talk about Apple real quick, right? Apple probably does almost every single step. It probably does every single step in this process besides the raw manufacturing of the chips, right? That has to go to some special lab in Asia, but Apple almost does everything inside its own company. So they actually get different components from various people, but they put it all together, right? Apple might design their own processor, but they might get the screen from somewhere else, the touch sensor from somewhere else, and then they take it all and they put it all together into a form factor, which is your iPhone. So just one point I wanted to throw in the mix in all this is that when you hear all these steps that we're talking about right now, sometimes one company is doing all of them, sometimes different companies do different parts of it, but you know, it's all different, all right? So everything we're describing is potentially a very special expertise of some company or a different company. All right, step number 7. Step number 6 was high-level software. Step number 7, I just have it labeled here as more software. So it's just more software. Let's keep talking about it. So as you get higher in the stack, right now we're almost at high level software, but as you get more and more into software, you have to do more and more customizations. Think about if a company makes a brand new hardware chip, right? It would really, really suck if that one hardware chip worked just on one platform, right? So Qualcomm makes this spanking new modem, right? They make this new cool modem chip, but if it only worked in an iPhone, it would defeat the whole purpose, right? That modem chip has to work in an iPhone, it's got to work in a Windows phone, it's got to work in a BlackBerry phone, it's got to work in an Android phone, so you have to customize it very much, right? And sticking some hardware into different platforms like that does require a significant amount of software customizations. So you design and fabricate and test the hardware really well, and all the low-level software works really well, but once you get into higher-level software, you have to make sure it still works on a variety of different platforms, right? So when I was working at Qualcomm, there's so many different product lines, right? Windows phones, they're gone now, but we had to do Windows phones, Android phones, different Android phones is a whole beast, Apple and so many different companies, right? But every single environment, every single potential software environment, right? BlackBerry is really different from Windows, but every single software environment required special custom things to make the hardware work. This is where the number of people start expanding, right? At higher level software levels, there's just so many more applications and customizations that it starts to kind of fan out a lot. All right, so let's just keep going up, and now we're at step number 8, and I call this step optimizations, but here's what I mean. All right, so we just talked about how everything is fanning out to different types of software up here, but let's just take one example. So let's just take iOS as an example. All right, iOS is Apple's software that sits on Apple's hardware as well as other people's hardware, but what makes iOS, I guess, particularly special is that it's heavily optimized for its own hardware. So step 8, the step we're on currently, that I'm calling optimizations, but the more fancy word for this step is called platform-dependent optimizations, and this is what it means. So just take Apple, for example, right? They own the whole stack. They literally own hardware design all the way up. So when you own the whole stack like this, which is pretty cool, but that also allows you the luxury of making really cool optimization techniques in your stuff, right? The Apple people developing the iOS software, they can actually write custom stuff that they know is going to perform well on Apple hardware, right? Apple software on Apple hardware, it's going to work well. You can imagine that the same people writing Android, for example, right? Think of all the different hardware that Android means, right? Just the operating system of Android, there's so many varieties of it, and it's supposed to run on so many different pieces of hardware, right? Which is going to make it a little crazy. Companies like Apple, when they control everything, it's actually a little nice for them because they know exactly how the hardware works. They know exactly what instructions are going to make that hardware super, super fast, and they're going to write their software for that. All right, guys, we're on step number 9. I think we can make it. This is much longer than I'm used to, so I think my voice is starting to get a little, I think my throat's getting a little dry, but anyways, push through, and we're on step number 9, and this one's going to be developer ecosystem. So if iOS was just vanilla iOS, it wouldn't be that good, right? Many of the reasons, the top reasons you use your smartphones is that you can get applications from various developers, right? Your friend can make an app and you can download it, right? So another really good thing at this level, from step 8, Apple was like optimizing their operating system, making it super good, but at step number 9, we have to develop an ecosystem for third-party developers. So at this level, what Apple kind of does is they just create a development platform, ecosystem. It's like the same word, but they just provide libraries so people like you and me can access cool things on the phone, right? They'll give you special libraries to use the camera, use the GPS, use motion sensors, right? And all those cool libraries, you can pick and choose and create really fun applications. So this ecosystem, Apple, it's not just Apple, right? Like Windows has it, Android has it. I'm just using Apple as a consistent example, but once they develop their software at a reasonable level, they need help from other people to make that software a much better user experience, and they develop cool libraries, they write good documentations, they make tutorials, and after they do that, all these developers come in and contribute their apps, all right? And that's a really cool part. All right, guys, this is it. Step number 10, last step in this whole sequence, this whole journey. But step 10, I'm sure you guys know where we're at right now, but we're at application software. So Apple has just created this cool mobile developing ecosystem for us. The last level of this whole thing is application software development, and it's when you and me, we just go, we read a tutorial, and we make an app. I did Apple iOS development for about 1.5 years or so. I thought it was really fun. It's definitely a little different way of thinking, but one thing that I liked about that in particular was that Apple's documentation was actually probably the best, most thorough documentation I've ever read, and I actually really appreciate that. And I'm sure if you're a developer, you always appreciate documentation. So that's one real big plus that I had. One big con is that you don't have so much freedom. You have to do everything the Apple way. I mean, they think what's the best way, but you know, sometimes it can feel a little restricting. But overall, this whole level, this whole ecosystem was provided by Apple, right? And you can see all the cool things that happen from that ecosystem, right? Instagram, Snapchat, all this stuff were possible because Apple created this whole platform for everyone. All right, guys, so that was the last step. I'm keeping this list up here, but step number 10 is application development, right? If you go back up or back down the stack, I guess, if you remember step number 1, we started at hardware design, and now we're at application development. So we went through a lot, and even though it's still like a very bird's eye view of the whole process, I think you have a better, maybe a better grasp of what the journey is kind of like, all right? I think in the other video, I just mentioned it in one sentence, so now I'm spending like 30 minutes on it. All right, guys, that's the end of the video. I'm personally wiped out. That was a lot more talking than I'm used to doing, but I think every single point we talked about here was actually really important. We went through a lot, but I skipped a lot of things. This was still a high-level type of talk, but that was a lot to go through, and that's just one example of kind of the whole stack. All right, so I hope you liked the video, hopefully made you more curious. I'm really tired right now, but next week I'll probably do something a little shorter, but please like the video, leave me a comment, ask me a question. Any questions, probably email me. Sometimes I try to respond to the comments, but it doesn't let me. Like the form on YouTube is messed up sometimes. So just email me. Happy to answer any questions, and have a great rest of the day. All right, take care.